Hey, everybody. Welcome to Dakari's 22nd virtual fire investigative training session. Today, we have an ATF supervisory special agent. Her name is Dawn Dodsworth, and she is the first one that I'm able to call doctor. She just finished with her doctoral dissertation on the Internet of Things that are connected to the internet and provide information and how we can use them in fire investigations. So without any further ado, Dawn, go ahead and take it over. Dr. Dawn.
Thank you, Bill. Thank you guys for tuning in. I really appreciate it. So this project was conceived probably about 3 or 4 years ago as part of my research for my doctoral dissertation at Oklahoma State University. And the particular reason I selected this subject was that I think there was really a significant need for it in the field, as well as it was something that I thought would really challenge me to step further across the line and kind of step into an area that was slightly outside of my comfort zone. So hopefully you can glean some information out of this study and use in your own personal and professional careers. So basically, the Internet of Things, connected building systems, and their use in fire investigation. So you may ask yourself, well, what exactly is the Internet of Things? And I know I asked myself this very early on as well. You may actually recognize the Internet of Things as something like an Alexa in your house that plays music, smart refrigerator, your Nest thermostat, maybe a Fitbit if you have a Fitbit. But basically, it's a network of linking various things together. Now, these things can be sensors and systems, communication equipment, but it essentially links things through sensors and communication equipment amongst themselves, between people, and amongst other things. So essentially, they're interrelated devices, machines and objects with unique identifiers that transfer data over networks without requiring any human interaction. They could be connected through Wi-Fi systems, through Bluetooth technology, routers, satellite, Ethernet, you name it, and it could be connected by that. Currently, there's about 50 billion things connected to the internet. So Internet of Things is so pervasive in our society, but as a result, so is the resulting data that an investigator can obtain from it. So why is this particular study important? Well, there was a couple of baseline issues that really needed to be addressed, and some bridges needed to be gapped. The first is a 2009 National Academy of Sciences report known as Strengthening Forensic Science in the US, A Path Forward. Essentially, the focus of the NAS report was to improve and increase effectiveness of various scientific disciplines via their recommendations as a result of their study. They found essentially that the field of fire investigation needed to be placed on a more scientific footing. They also concluded that there was essentially a paucity of research related to different fire effects and patterns and their interpretation by the investigator. Another significant issue were opinions of several opposing experts in the field of study, such as John Lentini and John DeHaan. And basically, the concern was, and the criticism of the subjective nature of interpretation of fire patterns. So essentially, interpretation of the collected data is more subjective in nature when it comes to a science such as fire investigation. So This study wanted to look at how these concerns could be addressed, how this gap could be bridged, and can we use everyday Internet of Things connected devices and systems to aid investigators in their fire investigation and their scene examination. So briefly, the purpose of the study was to explore the utilization of Internet of Things data. We also wanted to look at the proper collection and application of that data. We wanted to address the NAS report and the concerns of subjectivity. And this really began with looking at how can we provide empirical support to these fire investigators through the use of hard data points. Also looking at how Internet of Things connected systems could provide timelines of events that occur during an incident, as well as the possibility of the tracing of fire progression throughout the structure. Essentially, giving an investigator an additional tool in their toolkit. So a brief background, there's several goals in fire investigation. The first, obviously, is to determine the area of fire origin. The second is to identify the cause of the fire. When we consider what the cause of the fire is, we're essentially looking at the ignition source, the first fuel ignited, the oxidizer, which is generally normal atmospheric oxygen, and the circumstances which bring the aforementioned together to cause the fire event. And then third is to be able to classify that fire. And one caveat here is classification system had been removed from the recent edition of NFPA 921, but your department's policy may still dictate that a classification of a fire needs to be made. As far as ATF, our CFI program policy specifically states in there that the CFI still classifies the fire. Now, looking at various data points for consideration when an investigator is opining an area of origin, there's three specific areas that a fire investigator can consider. The first is listed as witness information and electronic data as a combination. And as we progress throughout this study, we're going to see where in the conclusion, I've recommended some specific changes to this. Number two are fire patterns. Now, a fire pattern is defined as a group of fire effects, and a fire effect is defined as an observable or measurable change in a material as a result of a fire. This could be a consumption of material, surface deposits, observed thermal effects, charring of an object, or a penetration. So essentially looking at the fire patterns to try to track back to the earliest source of fire damage. Not necessarily the greatest source, but the earliest source. And number three, fire dynamics. One of the biggest things that investigators need to consider when they're processing a scene and they're looking at these various data points is they need to keep everything within proper context. And by context, essentially it's, you don't want to look at a data point in a vacuum, just individually in and of itself. You need to look at that data point in conjunction with your other data points that you're observing and actually take them together. So it's essentially, if I'm reading a book and I just read one word in a sentence, that word may not necessarily have the same context as if I read that word as part of a sentence or as part of a paragraph. So it's the same thing with conducting a fire scene examination. Another issue is that looking at these various data points, it's dependent on the investigator. It's dependent on the investigator's knowledge, training, and experience. So sometimes there could potentially be a subjective interpretation because it's really dependent on the investigator. So conclusions can be occasionally elusive. Just a brief look at the scientific method. I actually was able to speak with Andy Cox during the course of my study. So I'd like to thank him for providing me some of these graphics on the scientific method. But essentially, the scientific method is defined as the systematic pursuit of knowledge involving recognizing the need and identifying the problem, defining specifically what that problem is, which in the case of a fire investigator, it would be needing to conduct an origin and cause of a specific fire. And then progressing down into the area of data collection and analysis and the development and testing of hypothesis, and then concluding with the selection of a final hypothesis. Now, when we look at these developing hypotheses and testing them, testing can include such physical testing as field testing and laboratory testing, or it could be merely the investigator's mental evaluation based on their knowledge, training, and experience if that potential hypothesis is in fact viable. And then at the end, selection of the final hypothesis that's been generated through the totality of the use of the scientific method. This is a very iterative process, and by iterative, that means some steps are generally revisited and reworked, constantly reevaluating, and just as you are able to determine that particular hypotheses are not viable, it may require collecting additional data and analyzing it in order to develop additional hypotheses. So when it comes to Internet of Things building systems and fires, a fire investigator really, first and foremost, must be able to identify that there are, in fact, systems present within the building. There also could be systems present that may be of use to an investigator in and on neighboring buildings as well. Each system or artifact can generate and or possess data. So the system or the sensor or the device can have local storage capability, and they also could potentially be stored within a cloud-based data storage or within a server. So essentially the fire investigator really, when they arrive on scene and speak to either if it's a residential structure, speak with the residents, or if it's some type of commercial business, speak with the owner, speak with the maintenance staff, but try to obtain as much information as to the systems present in the building as possible. Now, the data that is produced by these systems can be autonomous. So by autonomous, it's not initiated by humans. Okay, so this could be the result of fire progression, smoke and heat progression throughout the building. So different data sources could be, a door or window alarm. Now, a door or window alarm could be the result of heat attack on that specific device or sensor, or in such a system that may be hardwired, it could be flame and heat impingement upon the specific connection that's running between the sensors and devices and the panel. Also, user commands for human initiated, motion alarms, which generally we can get from burglar alarm systems. A motion alarm might not necessarily mean somebody's in the building. Motion alarm could mean that there is smoke traveling into that specific area. Smoke alarm activations, sprinkler activations, it really runs the gamut. But the investigator really kind of needs to be familiar with what systems are present first. And then, as we're going to speak about a little bit later, how those particular systems operate and are constructed so that we as investigators can get contextual data that we could use in our scene processing in our fire investigation. Now, there's certain concerns with using these types of systems, and we're going to get into this a little bit more a little bit later. But looking at access to the data, how can the data be retrieved? Once the data is retrieved, is it in a format that's easily accessible to the investigator? Reviewing that data and utilizing that data. Also, Internet of Things data falls under the Fourth Amendment. So an investigator is probably going to need consent or a warrant in order to obtain that data. Another issue is the data could potentially be lost. So the data needs to be preserved, because if the system is still operating in some manner, or if the system loses power, that data could be erased, it could be overwritten. So investigators need to keep that in mind. And another big issue, which we will basically pound into your heads, is being able to synchronize the times from these different data sources so that you have a normalized chain of events, or a normalized timeline to look at. Basically, the process for utilizing any Internet of Things connected system or device follows this progression that you see on this slide, which what we just spoke about. Identifying the system, being able to document that system, asking for if the building or the installer has some type of schematic as to the location of the devices and sensors. Is it a wireless system? If it's a wireless system, there are certain data points that are going to be useful. If it is a system that is hardwired in, there's other considerations investigators need to think about. We're going to touch on that a little bit later. But then collecting that data, examining that data, then subsequently applying everything that you have obtained to that scene. And it could be through the use of having a schematic of your system, and then actually having a schematic of your building and almost overlaying that information to tell the story. And that is done through essentially an analysis phase, and then coming to the conclusion after you utilize that data. So the nature of my study took a mixed methods approach. And what I mean by mixed methods approach was the integration of qualitative and quantitative data. I utilized what's called a sequential explanatory design, which essentially uses two distinct phases, one after the other. So initially, there was a quantitative or numeric data collection and analysis phase, followed immediately by a qualitative or textual data collection and analysis. This particular study chose to apply the priority to the second or qualitative phase of the study. And I'll kind of get into a little bit why that was chosen, but essentially it provides insight into the story of the quantitative data that was obtained. It really provided a comprehensive exploration of the data from the participants' viewpoints. So I really wanted to get the opinions and the experience and the thoughts of the subject matter experts that I spoke to throughout the course of my study. As far as population and sampling, this particular study focused on subject matter experts specifically from the Bureau of Alcohol, Tobacco, and Firearms. First and foremost, the certified fire investigator cadre of ATF, who are the only federal experts in origin and cause determination. Secondly, members of the ATF's National Response Team, which is essentially a hand-collected cadre of experts in the field of fire investigation, explosion investigation, regular street agents who assist with interviews, and our engineers. And essentially, our personnel attempt to get boots on the ground within 24 hours after a significant incident. So these folks are the ones that are really processing these big, significant scenes. And finally, personnel from our fire research lab, specifically our engineers, both electrical engineers and fire protection engineers. So it formed a non-probability sampling in which I relied upon my own judgment when choosing members of the population to participate in the study. I wanted people that were really kind of on the cutting edge of fire investigation and new emerging trends of fire investigation. So originally it was a non-probability sampling, but then as I was able to reach out to these various experts and begin to collect different case examples, I also used what could be known as purposive sampling, which is known as selective or subjective sampling. Basically, I purposely were selecting distinct members of the group. And then what I did was I stratified it into 3 distinct groupings. So first are our CFIs, second are our electrical engineers, and third are our fire protection engineers. But the result of this study really was an integration of the quantitative and qualitative data. Once I stratified this sample into these 3 distinct groups, then I selected 2 subject matter experts from each group randomly for interviews. Prior to the interview, obviously I obtained consent from that subject matter expert to be a part of this study. Next, research questions had to be developed. Specifically, what was this study going to focus upon? And generally, it's focusing on the overall result of the utilization of Internet of Things data during fire scene processing and the resultant origin determination. Next, I wanted to understand what information would be available to investigators. In order to understand what information would be available, we really have to understand the basic operations of these various types of systems. And then third was the fact that different systems provide different data related to a fire event. I realize this is a very busy slide with kind of a lot of lists here, but what I really want you to take out of this is the general flow of data throughout the course of the study. Starting with literature review in order to get background information, then starting to develop the quantitative data collection phase, which was essentially started off with my sending out an email request, asking our various subject matter experts if they had ever been involved in a scene where this particular data was used, and then essentially categorizing and looking at that data and then selecting participants and case reviews for this specific study, and then working our way through the qualitative data by means of reviewing documents such as expert reports from our fire protection engineers and our electrical engineers, our origin and cause reports, and conducting telephonic interviews. That provided me with the textual data, which then I was able to send out to a neutral third party to have transcribed. And then I had the subject matter experts review the transcription of their interview to make sure that that data that was provided in the transcription was accurate of what their statements were. And then utilizing a process of coding and analysis of the verbiage utilized by the experts to actually look at the development of themes in their statements, and then finally use that to interpret and explain the results. Again, the ultimate goals of this study were to reduce the potential for error, identify and increase sources of empirical data for the fire investigator, and not only for myself to become more familiar with this process, but to develop a mechanism to explain this process to other fire investigators so that they could also use it in their toolbox. Now, what's very important when we're looking at fire investigation is that the fire cause is going to be located within the area of origin. So if the area of origin is not correctly identified, then ultimately the cause of the fire will also be incorrect. So really reducing the potential for error will increase our accuracy when we're coming to these conclusions in a fire scene. Essentially, I've already discussed this, but we wanted to really ensure that there was credibility and reliability in the study. So as the researcher, I wanted to make sure that, you know, I was able to field test the interview template to make sure that each interview was approached uniformly in order to gather consistent data, reduction of bias, any type of bias, because of the fact that I was the researcher in this study, but I'm also a certified fire investigator. I did not want my own personal bias to be reflected in my study and in the results. So that is a large reason why these interviews were audio recorded and then transcribed by a neutral third party. But constantly I was reflecting upon the information I was coming across and jotting down notes to myself so that I could track the process of my own data analysis of what I was obtaining from not only the reports, but also the subject matter experts. And then at the conclusion, when I began writing my research, I had various subject matter experts conducting technical reviews of all different portions of my study. Some did a complete technical review of my entire paper. Some I just had to do a technical review of the specific case studies for accuracy. But really, it's all about making sure that the study had credibility to it, it could be transferable to other instances, and that the results were reliable. So looking at the participants, and these are just the participants that were interviewed, it was just a vast array of experience. These 6 participants combined for a total of approximately 3,500 fire scenes with a total of 102 years of collective fire investigation experience. So this slide really shows the knowledge, training, education, and experience of those subject matter experts who were selected to take part in the study, all of which had an undergraduate degree, and 4 of the 6 had graduate degrees. So on a previous slide, we're talking about collection of the data. So there was various sources of information that was utilized in the study to include texts and technical manuals, scholarly articles, origin and cause reports, engineering reports, my own self-reflective memoing process. But it really was starting off with the literature review to provide some type of foundational development and identifying the specific issues that needed to be approached in this study. And then looking at the topic and coming up with interview templates, looking at the various situations that were covered by our experts in these scenes, and really focusing on creating an unbiased approach to the data and the conclusions. The subject matter interview process started in early May of this year, and it concluded in mid-June. But the big focus for the interviewing was I wanted the point of view of our subject matter experts. You know, you read a technical report, and obviously it's going to be very matter of fact, but I really wanted some experience and opinion and essentially some color commentary to those expert reports. And I really wanted to get a sense of what the participants thought about using this data and this specific process in their approach to fire scene examination. This slide kind of just shows you the way that the different language utilized by the subject matter experts were broken down. So it really progressed from the simple, which is at the top, the core concept, which is a simple concept that I would come across when looking at the textual data, and then progressing downward and splitting it into different categories and then very specific codes. So essentially going from the simple to the complex, but it was also a cyclical pattern of word analysis. So coding essentially is the process through which data are fractured, conceptualized, and reintegrated. It's tied together with different pieces of data into different recognizable clusters. So while going through this process of breaking down and coding and reintegrating, really I was asking questions such as what, who, how, when, where, how long, why, and what for. This slide just basically shows us kind of a general breakdown of a very specific investigative process, and then looking at the individual properties of those concepts, such as various human factors, different challenges faced by subject matter experts, and then looking at the results. But what we're really doing is we're looking at specific traits, casual conditions encountered, the context, both specific and general, various measurable concepts, scope and magnitude, action and various interaction, and consequences. So when you look at, let's just take, for example, number 2, challenges. Well, some of the challenges encountered by our subject matter experts when using Internet of Things data is there really needs to be a knowledge of the type of system and its operation, a knowledge as to how the system is configured and how it's constructed. Is it a wireless system? Is it a hardwired system? If it's a hardwired system, how are those runs constructed or laid out? Are they below the ceiling? Are they above the ceiling? You know, looking at the various sensors and devices, are they made of plastic? Are they made of metal? Looking at the various types of volume of data that could be obtained, and then looking at the survivability of locally stored data. Is it going to be intact? Is it gone? That's various challenges that these investigators have to consider when utilizing this particular technique. But at the end, a successful and proper application of this can assist the fire investigator in obtaining more confidence in their conclusion. Looking at the various themes and mapping out the various verbiage from these subject matter experts. These obviously are not exhaustive lists, but these are just specifically what were mentioned during the subject matter experts interviews. So they were split up into various, you look at the big categories, you could see on the right-hand side, Internet of Things systems, and then you actually have a flow downward. Sometimes it seemed to me to be better to place actually that big category in the middle and then flow outward from it. But it really provides a rich visual of the textual data that was received. Again, when we're talking about context, the investigator must fully understand and assess the circumstances related to an event or situation in order for clear, concise, and accurate meaning to be drawn. As we said before, investigator needs to know the type of system, how that system was constructed, how it's laid out, what are the location of the devices and sensors, and the normalization and syncing of times need to be included within that context. And then also Internet of Things use. What can this data essentially be utilized for by the investigator? Statement evaluation. Are your witnesses telling the truth? Is it possible that they're telling you that they weren't in an area and they actually were in an area? What time the fire may have been ignited, looking at various environmental control systems, looking at heat within the structure, heat rise, and humidity measurements. You could use it to assist with area of origin and even fire cause. If there's not supposed to be anybody within a residence and you actually have a system being unarmed and then armed again, followed by a fire, that could be potentially used as a data point to support, obviously not in and of itself, but it could be used as a supportive data piece for a potential incendiary classification of a fire. Also looking at the progression of the fire throughout the structure, and then also looking at potential ignition of the fire. What are the activations of lights and appliances in relation to where your Internet of Things systems and devices are? Now, when conducting an interpretation of all of the data gleaned from our subject matter experts, first and foremost, every single expert that took part in this study emphasized the need for proper context in the interpretation and application of the data received. Primary use, 83% of our subject matter experts mentioned the development of a timeline related to the incident. And then subsequently, there was actually additional uses for the Internet of Things data, which include the creation of hard times, the determination of various sequences and patterns within the structure or involving the structure or system, progression of fire, and also to narrow down the area of origin. When we look at further interpretation of the data provided by our experts, looking at both strengths and weaknesses, a majority of our subject matter experts mentioned more than one. Some of these were actually really interesting to look at, such as the superiority to witness statements, additional reliability more so than fire patterns, the unbiased nature of an activation of a sensor or device, the fact that it's truly reliable and it's very hard to argue against a physical timestamp at a specific point in time in an event, once again with the proper context that that timestamp has been normalized. And then the two most prevalent weaknesses mentioned were Number one, the potential for some type of systematic error, which is needing the proper context and needing to normalize the time. And then number two, the ability to access the data, either by means of having to obtain it via the use of a search warrant or extracting the data and then having it be in such a format that it is not easily readable and interpretive by the investigator. You may need to actually have an engineer that specializes with that specific system. But overall, the opinions of our subject matter experts with regard to this particular data being used in fire investigation were actually very positive. They had really a lot of great things to say. It was very helpful, unbiased. The system is purely responsive to the circumstances of the environment. Now, when we take the textual data that we received from our subject matter experts, now we're going to kind of switch gears and we're going to start to look at some very specific case examples of where Internet of Things data was utilized in a fire scene examination. Now, our first case study looks at Wine Central, which was this big, large wine storage warehouse in California. The size of the building was just under 250,000 square feet. And the system that was utilized was the smoke detectors and then also an environmental control system within the structure. The timeline after it was normalized was actually essentially put on a table, and then they had a schematic of that area of the structure along with the system layout. So when you look at the photo on the right-hand side, in conjunction with the table on the left, within that black box, kind of at the center of that picture, you could see where the various beam smoke detectors activate. Now, essentially, these beam detectors, they activate when the beam that is sent out from that system is obscured. These detectors project a beam of light across large areas, which is then reflected back. They're used in areas where standard detectors would really be uneconomical due to either the size or the height of the area being protected. So looking at the beam detector activations, the first three to activate is number 5, 6, and 8, with 5 being closest to the fire and beam detector number 8 being the furthest from the fire within that black box. Of importance to note was that detector 7, just kind of in the middle of that black box, had actually been disconnected prior to the fire, but research from the investigators showed that it was not related to any type of nefarious activity. The area of the origin essentially was determined to be the mezzanine of the structure. Investigators actually had some positive samples come back from the lab for gasoline on nearby cardboard boxes, and they actually located an open propane torch that was in the area. The fire was determined by investigators to be an incendiary fire, and a defendant was actually sentenced to 27 years in prison on 19 federal charges, including arson. Our next case study involves a double firefighter line of duty death in Kansas City, Missouri. And in this specific instance, we're going to be looking at smart meters. The building was 3 stories with 4 commercial occupancies on the first floor and 16 apartments on the 2 stories above the first floor. The Internet of Things data came from smart meters, which essentially measure and read electrical power consumption in 15-minute intervals. They then transmit this data every 4 hours, but these systems also had internal memory. Investigators compared the data usage for 2 weeks prior to the incident in order to establish a pattern of both house power usage, which is the entire usage generally in the building, and then looking at the usage of each specific unit. On the day of the fire, the investigators extracted the data and were looking at changes in the power usage and also looking at when that power reached zero. And they were able to determine that the unit of origin, which was L&N Nails and Spa, actually began to slowly lose power as circuits were being impinged upon by thermal activity. And that particular unit, as you can see in the top left figure and in the middle figure, is a comparison on the day of the incident between the house power and L&N Nail Salon. You could actually see that system being impacted earlier than the general house power. As a result, the area of origin of this fire was determined to be in the northeast corner of the first floor storage room of L&N Nail Salon and Spa. So if you look at the lower right photograph that actually shows the scene post-fire, that red box is where L&N Salon and Spa was located. And then if you look into the upper left-hand corner of that red box, that essentially was our area of origin. This fire was classified as an incendiary fire, open flame ignition to available combustibles, with one of the possible motivating factors was to collect insurance money. The defendant was charged with 2 counts of murder as well as arson charges and received a 74-year prison sentence. The next case-specific example we're going to look at is a Wi-Fi system within a structure. This particular building involved a single-story auto dealership. Investigators examined the Wi-Fi system and compared the failure times of the various individual antennas. So if you look in this background photo here, you can see this green circle right up here that I'm circling. That actually is of particular interest. We'll look over here, the upper right-hand side, you can see a schematic of the entire structure with these yellow lines going to each individual Wi-Fi access point. And you'll see here, this black box shows us right here, this circle, which was the one, if you look to the left, right here near our employee break room. That was determined to be the first access point to become unreachable, and it was also the closest to the employee break room. All the other Wi-Fi access points became unreachable nearly simultaneously after the first one. Investigators, while working that scene, also compared results with electrical arc artifacts, which essentially you could see in this background photo as these red X's on the schematic. The area of origin ended up being determined by investigators as the employee break room, which is right here in the center of the left-hand side. And then also in our upper schematic, you can see the red box around our employee break room. Unfortunately, due to the large number of appliances within the employee break room, investigators were not able to determine a specific appliance or fixture that could have been the specific cause of the fire. So as a result, the fire was classified as undetermined, although there was no evidence of an intentionally set fire. Our next case study involves a single-story commercial warehouse in Hillsborough, New Jersey. This fire resulted in the complete destruction of one building and a partial destruction of a second building. Fire was observed coming through the roof of a portion of the building upon the arrival of the fire department. Investigators in this particular scene utilized Internet of Things data from fire alarms and sprinkler system activations in order to support witness statements by the various responding agencies and employees. If you look down here at the lower right, you could actually see some of the conclusions that were able to be drawn from the various system activations. And the area of origin of this fire was determined to be within a high rack storage area in building 14, the west side of unit C, which right here in this red box was determined to be the area of origin. So you can see there's actually a significant decrease from the overall size of the building to being able to really narrow down our area of origin. And if you look down in your lower left, this is your scene. So if you're able to narrow it down to a portion of a corner of a structure with that much damage in an incident where the fire burned for that length of time, it really is a success to utilize these particular systems and devices. Ultimately, the cause of the fire was undetermined. Again, there was no evidence of any type of a set fire, but investigators could not eliminate the lighting in that area. Moving on to Golf Country Club in Missouri. This involved actually it was ultimately a 4-story structure. It was 2 stories above ground and 2 stories below ground. So it had a basement and a sub-basement. The flames were initially reported at the rear of the structure, and investigators looked at and analyzed the burglar alarm system to include motion sensors and door alarms, as well as the activation sequence of the smoke detectors and fire alarm system. The Internet of Things data supported an exterior fire on or around the rear deck, which then progressed inside of the building. So if you look here in the upper left-hand side, this red box indicates the area of fire origin. And as you look, these various red numbers indicate a different sequence of events for our different systems. And by analyzing the activations of these different portions of our systems, the investigators were ultimately able to, they were actually able to analyze and track back the area of origin to this rear deck. And it supported early witness statements and photographs that were provided to investigators. The cause of the fire was determined to be a cigarette butt that was discarded into a plastic planter, and the classification of this fire was accidental. Next, we'll look at a single-story commercial fruit warehouse and packaging plant in southern Washington. The structure actually accounted for 10% of the U.S. pear crop, which was all ultimately destroyed in this fire. The overall size of the building was a little bit over 100,000 square feet. There was a sprinkler system present within the structure, but it had been installed in 1973, and as a result, it was not monitored or recorded. Investigators in this particular fire used burglar alarm activations for various motion detectors and door alarms within the structure, as well as the overall system failure. Luckily, in this specific instance, investigators were able to obtain very thorough wiring diagrams for the video surveillance system within the structure, and were able to map out the video signal losses in sequence. This is after time normalization. So if you look on the screen, you'll see in the lower left-hand side, this table that's color-coded. This shows our different activation sequences and signal losses of our video surveillance system. And then what investigators were able to do was actually overlap these instances with the scene schematic. And basically, by looking at where all of these signal losses and other issues are occurring, the investigators were actually able to narrow down the area of origin within this red box, which essentially incorporated the footprint of the 2 employee break rooms. Ultimately, the cause of the fire could not be determined because of the easily accessible areas of the sides of these buildings where various beltways were coming through the structure. An incendiary fire could not be eliminated, but also there were various competing hypotheses related to potential accidental causes as well. So ultimately, the classification of the fire was undetermined. But what we have to remember as fire investigators is just because you have an undetermined fire, it's not necessarily a failure in your scene processing and your investigation. It is just you don't have enough data at that time to be able to definitively classify that fire. You may end up down the road obtaining additional data in which then you can classify a fire. But what we need to remember at this point is, according to the new NFPA 921 edition, that section on classification has been removed, but you'll have to really refer to your departmental policy as far as if you need to classify your fires as an investigator working for your agency. Moving on to the next example we have, this scene involved a 2-story residential nursing home, which the fire resulted in 4 deaths and multiple injuries to the residents. Investigators looked at smoke alarm and fire sprinkler activations as well as notifications. And this data was used to support witness statements from residents, reporting parties, and responding agencies. As a result, the fire was determined to have originated exterior of the structure within the rear covered patio. So if you look at this schematic here, where my mouse is, this rear covered patio is our area of origin of this large structure. You could see the photo of it in the background, the degree of damage that occurred to this building. But if you look at this schematic, you'll see the various numbers that are coded in different colors dependent on the location of the activation or alarm. And ultimately, the investigators were able to track that back and look at not only where the area of origin was, but then you could also essentially, through looking at these various activations and notifications, you could track the progression of the heat, smoke, and fire throughout the structure. The fire ultimately progressed interior through various penetrations in the exterior of the building to include the eaves and windows that had self-ventilated. The cause of the fire, unfortunately, they could not eliminate smoking materials. And they also, due to the ease of access of that bag covered patio area, investigators could not eliminate the potential for an intentionally set fire. So ultimately, this fire was classified as undetermined. Our next example comes to us from Michigan. This is actually a pretty good example of not having enough information to provide you with proper context. So this particular scene involved a single-story commercial warehouse for automotive parts and operations. The physical layout of the burglar alarm and fire alarm systems could not be ascertained by the investigators. So they did not have enough data as to where the devices and sensors were located or anything else related to the system, other than the fact that there was a system in the building. As a result, the data could not be placed within the proper context by looking at the various activations and trouble alarms that were received and ultimately mapped out on our schematic here, and any type of determining or narrowing down an area of origin. So ultimately, the area of origin was just limited to the building footprint, which was 370,000 square feet. And ultimately, there were numerous competing hypotheses which couldn't be eliminated, so the fire was classified as undetermined. So what does this all tell us? Well, it tells us several different things that we must consider. First and foremost is looking at the system and device and sensor type. In order to understand this, we as investigators will understand what manner in which the system or device may activate. Understanding the construction of the devices and sensors assists us as investigators in understanding how these specific devices and sensors can fail. For example, if you're looking at the ability of plastic versus metal and its ability to withstand heat, it's going to tell us a lot to know that, hey, these sensors and devices were plastic, they're not going to hold up as long and may fail significantly earlier, potentially, than metal sensors or devices. How was the system installed? Was it wired or wireless? We also need to try to ascertain the orientation of the feeds if the system was wired. How were they run? What orientation were they? Where specifically were they located? Were they located above the ceiling where they may be protected a little bit longer? Or were they located below the ceiling? Location of the devices and sensors within the building, such as schematics. Anytime you could obtain a schematic of the system, either from maybe the building manager, or occasionally you can get this data from the installer themselves, it is a significant assistance to you as an investigator in order to give you the proper perspective and context with regard to what you're looking at as far as the data that you've obtained. Critical to synchronize the timestamps of the data you're receiving. Otherwise, you're going to be essentially comparing apples to oranges. So what we utilize with ATF is time.gov. And I believe that Dakari actually has a segment on timelines, if I recall correctly.
Yeah, we do, Don. I'll just mention that right now. Thanks. It's session number 4. So if you go to our website and look for that, that was by Trevor Maynard, a former engineer with our research lab. So thanks for mentioning that.
Sure. Yeah, I think it actually might be a good good segue to you when you have time to actually sit and watch that session, because it really intertwines really well with what we're discussing here at this point. And then finally, the proper interpretation and application of the data. Again, proper context of the data with regard to the totality of the scene is critical. One of the issues that we come across when utilizing Internet of Things data is the potential for human error. So when we're looking at extracting the data, applying the data, and interpreting the data, there is a greater chance for human error, either in error in the collection of the data or error in the interpretation of the data. Now, this is really another very busy slide, but what I want you to really focus on is looking over to the left-hand side here and looking at all the various potential ways that humans in our fallible nature can make mistakes. And it's not saying that these mistakes are intentional. They could just simply be slips and lapses. But we have failures of execution and failures of planning. Looking at the various types of error frequencies committed by individuals, skills-based error involves slips and lapses in the performance of an individual. The person actually has the correct intentions, but the execution was actually flawed. So 61% of the time an error occurs, it's generally going to be skills-based errors. When we look at rules-based errors, it's the next most frequent, and these could be caused by an erroneous perception of the situation or by omissions in the application of a rule or procedure. So essentially, the individual is disregarding the rules of how something is to occur. And then finally, we have knowledge-based errors, which involve mistakes due to incomplete or inaccurate understanding, overconfidence, or some type of cognitive strain. The interesting thing to consider is skills-based errors. People can generally detect these skill-based errors on average about 86% of the time. They're generally more recoverable because there's usually immediate feedback that the action didn't work. Whereas when we go down to rules-based errors, the feedback tends to be a little more problematic, and the immediate response essentially is you getting kind of what you asked for, but it's not as immediate feedback as the skills-based errors. It might eventually just be your activity or your lapse, your mistake catching back up with you at a later date. And then finally, knowledge-based errors is not having all the relevant information available at the planning stage. Generally, knowledge-based areas are detected and corrected only about 25% of the time. So when we look at Internet of Things data error, we actually have a number of potential issues here, which could be the incompleteness of the data. Perhaps the person recovering the data has failed to acquire all of the relevant information. The information from the devices and sensors may have been overwritten, may not be available anymore. There just may be a failure to understand that these potential devices and sensors may have a local storage capacity. Inaccuracy, which ultimately we're looking back at time normalization and synchronization again. So the information is not accurately reported. And then basically the conclusion could potentially be some type of misinterpretation of the data by forming an incorrect understanding of the data that you do have. So there's numerous ways to mitigate this. As I said, I was going to drive this into your heads, but ensuring that your timestamps are normalized. Using the proper personnel to access and interpret the data. As an investigator, you're not necessarily trained in the proper manner to extract this data. So a lot of times these systems, you may actually have to contact the company and they may send out an engineer that is specifically trained to deal with data recovery from that specific type of system. Again, understanding the context of the information. So you need to have a thorough appreciation and understanding for the various system types and installations, constructions, and layout within the affected structure. Conclusions reached by this study. Really the unmatched reliability, and as far as the information being unbiased and actual time stamped, was a significant conclusion really reached by majority of our subject matter experts. Hard times, having the actual time an event took place as opposed to an estimate or what we would call a soft time. The removal of subjectivity, using empirical data which ensures accuracy, quality, and integrity of the data points. This data can assist with narrowing down an area of origin. It can also assist with considering your fire progression throughout the structure, and then also with potential cause hypotheses. Internet of Things data can provide investigators with a degree of confidence in their conclusions as to the area of origin. Weaknesses, as we've spoke before, the accessibility of the data. It's covered by Fourth Amendment protections and may very well need a search warrant. And again, as we've seen previously, the data may be coded and as a result may be difficult to interpret. So you may need to bring in an additional expert to look at that data and interpret it. The need for context is just critical, so must ensure that the time is normalized. If the time is not normalized, it can lead to a very inaccurate timeline for the event. Understanding the physical layout of the system, the device and sensor construction, and the installation. So as a result of this study, a couple of recommendations were considered. The first one is that results of this research really need to be shared in both publication and oral presentation. Oral presentation and the fact that I'm speaking to you today about this study, and also the dissertation where all this data is in its entirety will be published on the ProQuest database. And also public inputs to NFPA 921 for their next edition. And there was actually two particular inputs that are being considered. The first one is to break off the electronic data and actually include Internet of Things in there, but essentially break it off from witness information. Witness information can tend to be more subjective in nature, whereas electronic and Internet of Things data is more empirical in nature. So I think it's really critical to separate those 2 points. Secondly, after speaking with another certified fire investigator with ATF, Andy Cox, is potentially to incorporate Internet of Things data into his proposal to 921, which would be to include Internet of Things data in a very similar nature as how arc mapping has been included in basically looking at fire effects and patterns with respect to system activation and other notifications. Reflecting on the experience as a whole, it really was not a surprise that there was low self-reporting by ATF subject matter experts. They all carry very significant caseloads and are out working in the field the majority of the time. So occasionally they may not have been checking their email, or it may have been an email that they observed and just got busy with something else and forgot to respond. But it was expected that there would be low self-reporting. The review of the various cases was extremely insightful in understanding and evaluating the process of utilizing Internet of Things data in fire scene examination. The interviews of the subject matter experts was really critical. And it was something at first that there was some guidance provided to me as a researcher to perhaps not conduct interviews of the subject matter experts. But ultimately, I concluded that I wanted to do these interviews, and I'm so happy that I did, because they really provided an enriching and colorful source of descriptive data through their own direct experiences, thoughts, and opinions about utilizing this specific technique. The different perspectives were really helpful. Each CFI, electrical engineer, and fire protection engineer added unique viewpoints as to these systems and the data that they could provide. So it really was a fantastic experience. And ultimately, at the conclusion of this study, I really learned quite a bit. And I hope I've been able to impart some of that onto you today. Recommendations for future research. There really needs to be some type of best practices as to how to obtain this data. What are the best ways to preserve it? So in my dissertation, I kind of have a whole section on recommendations for additional research that should be done. Number 2 is a step-by-step list for how to request the data, perhaps having contact information for these various companies and various experts that may be needed to interpret the data. And then maybe coming up with some type of a flow chart to really allow the investigator to go through the process unimpeded. Another point that really needs to be considered is how can this information then be applied to smaller scenes, such as single family residences and even vehicles. How can we take data maybe from a Nest thermostat or a Ring doorbell or a smart refrigerator or a GPS in a vehicle? How can we use that to assist us in area of origin and fire progression of these smaller scenes? And finally, and most important, is the potential for acceptance or exclusion issues within court of this Internet of Things data regarding various Daubert challenges. That is something that really could be a complete separate paper in and of itself. With that, my presentation is all completed, so I really appreciate your time today. Thank you.
Hey, Don, thank you so much for doing this for us. We really appreciate it. Like Dr. Dodsworth mentioned in the presentation, there is another Dakari session, which you heard a lot about time and normalization, and that is session number 4. Dr. Dodsworth is going to give us 10 questions. We'll make that into a test for you, and you can find that on our website, which is Dakari, DCARIWI.org. So, Dr. Dodsworth, thank you so much, and we really appreciate it.
Thank you.